Hey there! Are you still reprocessing all the data every time you run your processing? If yes, then you're burning money, especially in Azure, because compute costs. It's totally different than it was on premises. And in this episode, I want to show you how to do it better, how to use this incremental pattern approach that allows you to process your data faster. And that's the pattern that is universal. It works on premises, it works in the cloud, it works in Databricks, in Fabric, in Snowflake, it works everywhere. So let's get started. Alright, so the topic for today is incremental processing of data. So first of all, let me explain why we care about this. So let's say this is our source data. That's the data that we use in our processing, whatever it is, database or some other source of information. And what usually happens is that 99% of our source data, it doesn't change day by day. It remains static. And only this small portion changes, like new rows are added that were produced the last day. Which simply means that if we process this 99% of data, this part, then there is really no point in reprocessing it every time because the source data didn't change. And what we should do instead is to focus on this small portion of data. Of course, provided that we don't calculate some averages over the whole dataset. But usually, we don't have to reprocess these huge amounts of data. And now, the second important thing is that processing in Azure or in cloud in general, it differs from on-premises. It differs because on-premises, our servers were probably up and running all the time during the whole night. And in fact, it didn't matter that much if the processing took 1 hour or 3 hours, as long as it managed to complete before the employees came to work in the morning, right? In cloud, it is totally different, because in cloud, you usually pay for the compute time. So the longer your processing takes, the more you pay. So you want to lower those costs. You want to make it as short as possible. And that's also the reason why a lift and shift of existing solution from on-prem to Azure, it might not necessarily lower costs. It might be quite the opposite. Alright, so does it mean that you should always try to process your data incrementally? No, it's not that simple. Basically, if your data set is pretty small, and if it doesn't take too much time, if it doesn't cost too much, then feel free to reprocess everything every time. Do the full load. And by full load, I mean the situation when you read all the source data every time you run your processing on the full data set, and then you delete the data that was already processed previously, and you replace it with the new data. A very simple, the simplest case. It is not always possible to implement this, especially if you need to track the history, but in some scenarios it is completely fine. On the other hand, if you go to Azure, if you start to use Spark either as Fabric or Databricks, then this engine, it was designed for huge amounts of data. And sooner or later, you might face those cases when you really need to process terabytes of data, which simply means that processing everything all the time, every time, will not work. It will be too costly and it will take too much time. And that's when incremental processing will be very useful. Alright, but what this incremental processing really is? And I like to ask this question on my interviews for data engineer positions. And what I very often hear is that, well, incremental processing is about processing only this small portion of data. And to handle this, we should use merge operation. That would decide whether we want to update or insert our data. And it's true partially, because in fact, incremental processing, it consists of two phases, when merge is the second part. But the first part is the part that I want to focus today. And in this part, we decide which data we need to read from the source, which data we need to use in our logic. And then once we have this small part of data processed, then we decide how to save it by using merge, insert, update, or whatever method we choose. So please remember that there are two parts. Find the data that we've got to process and then decide what to do with it. Alright, so let's position this incremental processing on the diagram. Where does it fit? And I will go with this generic design that quite well describes a typical BI solution. Alright, so as always, we've got some data sources. So this is some kind of a database. It can be on premises, it can be in cloud, Azure, GCP, Amazon, whatever. We might have some files, CSVs, Excels, text files, you name it. We've got some APIs, we might have some streaming data, different type of sources. And then what we usually do, we ingest this data into a data lake. We dump it in the form that represents or that mimics the data that was originally available. And to make it work, we usually use a data lake. So let me draw this huge data lake here. So this is a data lake. And now, in real life, we might use multiple instances of data lakes. Here, it's just a conceptual view. And we know that we like to follow this layered approach that sometimes is called medallion architecture. And please remember that it is just a name, this medallion architecture. That simply means that we split our processing into various layers, like gold, silver, and bronze. But you can call them however you want. It's up to you. The important thing is that those layers, they differ by the means of data quality, number of transformations, number of business logic, and type of business logic. It depends on the level of how trustworthy this data is. But in this example, let's go with this traditional bronze, silver, gold approach. But what I will add at the beginning here is this landing or raw layer when we just dump the data as it is, without any transformations. Let's call it raw. And we know that we will store this data as files, as JSON, Parquets, CSVs, whatever, the type that corresponds to the original data type. Somehow we do this. And usually we partition the data here on a data lake by ingestion date, by the date when this data was loaded to a data lake, to Azure. And there are various ways we could do this ingest part. We could use, let's say, Data Factory, we could use Fabric, we could use third-party tools like Fivetran, or whatever. It's not important at this scenario when I want to talk about incremental processing. Then, once we've got the data in the raw layer, we want to convert it into the Delta Lake format. So instead of files, we would work with tables. So let's say you've got 3 tables in the bronze layer. And somehow this data has to be loaded here. And again, there are various approaches how to handle this. One of them is to, for example, use autoloader that is a part of Databricks. Autoloader. And I've got an episode that talks about this stuff, how to set it up. Now, once the data is in bronze layer, we've got those additional layers like silver and gold, or however you want to call them. It's up to you. In this scenario, let's assume that we've got 2 tables in each of those layers. 2 in silver and 2 in gold. And we need to implement our processing. Let's say it works like this. And that's where incremental processing comes into the play, because we want to focus here how to process the data from the bronze to silver and how to process the data from silver to gold incrementally. So that's the place when the incremental pattern works. In some cases it might be also applied here, but I want to focus on those two layers. Alright, so now before we go further, let's talk about the difference in those layers, bronze and silver and gold. The thing is that our bronze layer, it follows this append only approach, at least in my example. So it is append only, which simply means that we only insert new data to it. We don't update, we don't delete. Which in turn means that we need only a single timestamp here, the time when a row was physically inserted to this table, because we'll need to have it to support our pattern. And let's call it insert timestamp. So again, this insert timestamp is the date and time that is set by our process that loads the data to this table, and it uses the current time when the row is physically inserted to the table. It has nothing to do with the time when the change originally appeared in the source. No, that's the wall clock time when we insert this row to this table. Then the situation changes when we move to silver and gold layers, because here we no longer only insert data, we insert and update. So we've got insert and update, and the same in the gold layer, insert and update, which means that probably we would like to keep 2 types of timestamps. The first one that tells us when we inserted the row to the table. Let's call it again insert timestamp, just to be consistent with the naming. And the same would be here on the gold layer, insert timestamp. But we also want to have the time of the last update of a given row. And let's call it update timestamp, and the same here. And again, those timestamps, they are collected at the time the insert or update operation happens, and they store the current time. So insert it represents the time when the row is inserted to the table. And the update timestamp, it represents the time of the last update of the row in the table. And by the way, this timestamp, this update timestamp is also set during the insert. So please remember about this because it will be important in a second when we talk about our pattern. Alright, so once we know what kind of timestamps we need, let's focus on processing this table. Let's call it silver 1. And for simplicity, let's say that it uses only the single bronze table. And we want to make sure that when we process this silver 1 table, we read only the small portion of data from the bronze table, the one that we have to read, instead of reading everything. Alright, so how does the pattern work? So basically, we will need a separate metadata table that will contain 2 types of information. Let me just switch the color. So we need a table name and timestamp. So that's our metadata table. Metadata table. That will be used to support our pattern. And apart from that, let's draw a timeline. So that's a time. And let's split it into some points. Let's say those ones. And let's give them some names like T1, T2, T3, T4, and so on. Alright, so let's start talking about the pattern. So that's how it works. And let's say that we start the processing, or we start our analysis here at T1. And let's say that at this moment, 1,000 of source rows was added. And by source rows, I mean this table that autoloader is populating whenever some source data appears as files in the row layer. So we've got 1,000 rows. Cool. Then let's say that at T2 here we start our processing. So we start the processing. And the pattern is as follows. As the processing starts, our SQL query or our process, it goes to the metadata table and it checks if it finds a record there that represents the table that we are processing right now. And because that's the first time we are running the process, the table is empty, the metadata table. So it doesn't find anything. And it will effectively read all source rows from our bronze table. And don't worry, I will explain how this comparison works in a second. Let's just move on with the example. So let's say that because it was the initial load, it took some time, but it succeeded. Everything went fine, and we are here at T4 when the processing completed. So what happens at this moment as the processing ends successfully is that we have to go to our metadata table and add or update information there to store the timestamp of the successful start time of the processing. So one more time. As the processing succeeds at the end, we go to the metadata table and we save there the start time of this processing. So in our case, it would be T2 that we want to save here in the timestamp column. So let's do this. So we save T2 as the timestamp that corresponds to the table that we are processing, which we called silver 1. And that's it. The processing stops. Let's also say that in the meantime, as we were processing the data at T3, another 100 rows was added to the source. That happens, right? Autoloader is constantly working, and whenever it detects some new data, it just adds them to the source table, to the bronze table. In our case, we probably didn't include those 100 rows because at the time we started the processing, those rows were not yet available. But we'll process them the next time we run the processing, so it's fine. And that's exactly what happens at T5. We run the processing again. And the pattern is again the same. We go to the metadata table and we check when was the last time we successfully processed this table. And this time, we find a row that matches our table, silver 1, and we retrieve this timestamp of the last successful start time, which is here. Which tells us, alright, it simply means that this processing, it has to include all the data that appeared after T2, that appeared after we started the last successful processing. Alright, but how to retrieve this data? Well, simple. That's why we have those various timestamps in our data. And we simply have to compare this timestamp with this insert timestamp here, right? And read from the bronze table only those rows that have the insert timestamp newer than the value recorded in the metadata table. And it will guarantee that we'll read all the rows that were inserted to the bronze table after we started the last successful processing. Which simply means in our case that we'll read those 100 rows and we'll process it. Now, let's say that we managed to process it. It took less time than previously because we had to process only a small portion of data. That's the whole goal of incremental processing, right? And it succeeded. And we are here at T6. And again, if the processing went fine, we've got to go to our metadata table and update the data here. So we've got to replace the timestamp with the timestamp of the start time of our processing, which is T5 in our case. So let me modify it. T5. That's it. And the process ends. So let's move on. Let's say that at T7 here, yet another set of rows was added. Let's say 20 additional source rows. And at T8 here, we again start our processing. But this time it will fail. The processing will fail. Maybe there was some issue with this data. Maybe there's null in some column that we didn't anticipate. Or maybe there were some networking issues. Or maybe our cluster just went down and didn't want to cooperate. Whatever. Remember that this type of issues in Azure can happen, those transient ones. So, processing starts at T8. Again, the same steps. Process goes to that metadata table, reads the last start time of the last successful processing, T5, and it reads from the source only newer rows, which simply in our case means those 20 rows. It starts to process them, but it fails. Something is bad. So at T9 the process stops. It failed. it didn't, and successfully it didn't route those rows to the silver table. And the very important thing is that if it fails, we do not update our metadata table. We don't touch it. We don't change the timestamp here because, well, it failed. So why does it matter? Let's say that we fix the issue, or maybe it was a temporary problem with Azure, and at T9 here we start the processing again. And again, process goes to our metadata table, reads the last timestamp, T5, and filters the source data to read only those. And take a look what happens. The process will again try to process those 20 rows that failed the last time, right? But this time, because we fixed the error, everything went fine. And at T11, we can successfully update the timestamp to the start time of this process, which would be T10, and so on and so on. And please note how cool this pattern is. It transparently handled the issue that we faced down the road. It was able to reprocess those 20 rows that it failed to process previously, right? We didn't have to do anything. It silently retried the processing because it knew that this data is new to the process, to this table, and it has to read them. Please also note how nicely it handled the data that appeared in the middle of the processing, those 100 rows. And if we used in the metadata table, if we save here the processing end time instead of processing start time, then we would miss those rows. We would skip them. That's why it is so important to record the start time, not the end time. And you have to do this only if the processing went fine. Alright, so let's move on. Basically, the same pattern, it works to any layer. The only thing that changes, let's say if you would like to apply it here for the gold layer, is that we would read a different table, silver in this case, and we would use a different timestamp column from the source table with which we would compare our timestamp from the metadata table. In this case, we would use this update timestamp because it represents the last update time of a row in the source table. So whenever it changes, we want to include it in our processing. Alright, cool. But what if we have a table like this one that uses multiple source tables? How to handle this? Again, the same. Nothing changes here. So basically, the query that we would write in all cases would be as follows. Select some columns from our source table, where, and then depending on the layer, you would use some, let's say, update timestamp is bigger than metadata timestamp. Metadata table timestamp. Alright, that's how it works. Now, if you use multiple source tables that you join here in your logic, let's say source table A, and then you use inner join source table B on some conditions, based on your logic, then you got to update your where clause. So this is the first table, right? And then you would use the OR logic. Or when update timestamp of the second table is bigger than our metadata table timestamp. That's it. Which simply means that this query, it would include data in case of changes in any of those tables. As simple as that. Now, you might have other tables here that are also used in a join, but they might not drive the change. That they might be some additional lookups, additional data that enrich your gold table. So it's up to you to decide which source tables should drive a new row or an update in your data. Usually it's just a subset of tables, maybe one or two those main tables that if something changes in them, you've got to include them. But that's depending on your specific case. And now, please note that we didn't talk about technology that will support this scenario. It simply is just a pattern. You can use SQL as here to implement this. And because SQL is so universal, you can apply it everywhere, on premises, in the cloud, in many places. Now, you might say, all right, that's too complex. Why should we bother with this stuff while I can use materialized views in Fabric or in Databricks that are advertised as the solutions that automatically detect changes in the source and refresh data automatically, processing only the changes that are required. Cool, great. If it meets your requirements, go with it, that's fine. Just please make sure to go to the documentation and read all the fine print. Read all the limitations that those technologies contain. And check in action, implement a proof of concept that will validate if it really performs incremental load and not a full load. Because that's the whole point, right? We want to process data incrementally. And this pattern that I'm showing you right now, it works everywhere. It is bottle tested. It simply works and it's technology agnostic. You can apply it everywhere. And there is one more cool thing that I want to talk about when using this pattern, namely dependencies. Very often, we've got a set of tables that we've got to process one after another. Let's say we've got A, B, and C. And they are processed as follows. A is processed first, and then B uses the outputs of A, and C uses the outputs of A as well. And all of them we would like to be processed incrementally. Cool. But let's say that A fails for some reason. It didn't process the data due to some bug or the data quality issue. What happens then? Well, let's say that if B and C were executed, then they would try to process all the data that A has, right? It might not include the latest set of stuff because, well, A failed, but that's fine. Let's see what happens if in A we fix the issue. We deploy, let's say, a new version of the code and we run the process again. Using this pattern, A will just process the data that it didn't process since the last time. and it would simply insert or update those new rows, right? Then when B and C are executed, they will just see this new data as fresh set of data that they have to process. So they will pick it for processing. And take a look that it doesn't require any manual configuration for B and C. They simply recognized new data on A, which is their source, and they knew that they have to process this data. And it works without any intervention, which is super cool. And one more thing about reprocessing of data. So let's say that, well, we did this stuff. We are here at T11, and we recognize that actually the fix we deployed, let's say here, it introduced another bug, and all the data that was processed here contains a bug. Invalid set of data is produced at the end, and we've got to deploy the fix and reprocess this part of the data. Not everything, because we know that the data from the past, it is fine. We just need to focus on the newer set of data. So how to do this? Well, simple. We just deploy the fix, and we go to the metadata table. We find the entry for our table that we want to process, and we update the timestamp to the point in time from which we want to reprocess the data. Let's say we want to do this from T4. Cool, let's do this. So that's T4. So what happens is that the next time our processing starts, it will read this updated timestamp from here, and it would know, alright, so I have to process all the data from my source that changed since T4. It might have already processed part of it, that's totally fine. It will reprocess it using the fixed logic. Now, you might wonder, alright, but wouldn't it cause any issues if we reprocess the same data again? The answer is no, it will not, because we will later decide what to do with this data. Do we want to insert it or update this? But that's the topic for the next time, when we'll talk about how to save the data that we just processed. Alright, and basically that's it. So to summarize, there are patterns like this one that I really like that are technology agnostic. You can use them on any platform and they simply work. If for some reason you don't want to use those fresh and shiny tools from Databricks or Fabric, you can always go to this battle-tested pattern that simply works. And it's relatively simple to implement. Once you do this, once you understand this, it will become quite simple, especially if you automate part of this. For example, if you use dbt, you can implement a post hook that automatically updates the metadata table. If you use stored procedures, you can have a common part that does the same. It works if you implement this as a notebook in a Fabric or Databricks. It works, the pattern, if we implement it as a data factory pipeline, because it is just a pattern. It is not tied to any specific technology. Alright, and that's it for today. Thanks for watching and see you next time. Take care.